Hello, my name is Jahit Barkroza. I'm from Çukurova University Computer Engineering Department. Today, I will give you a brief introduction to the concept subject natural language processing in 20 minutes. The content, we will talk about what is NLP, the definition and the goal, and then NLP applications. I will give you some examples, and then common terms in NLP, then history of NLP. We will start from 1940s and to the modern day. And then leading algorithms, RNN, LSTM, and attention-based mechanisms I will talk about briefly. And then common problems in NLP. And I will finish with NLP projects. I will show some of my projects' outputs. And then the most up-to-date, the best projects. So what is natural language processing? Natural language processing has to be on natural language occurring texts. So, what are natural languages? Turkish, English, French, these are natural languages. And what are not natural languages are programming languages, are not natural. And it must be on texts. So, you might ask, can speech natural language processing? Well, yes. But you need to transform the speech to the text to work on it. And then the goal is achieving human-like language processing. You can think as understanding the language, etc. You can on the right you can see the domain of NLP. It's under the domain of AI, and there are some intersections with machine learning and deep learning. NLP applications. Question answering is concerned with building systems that automatically answer questions posed by humans in a natural language. Text summarization is the process of turning larger documents into shorter and more precise paragraphs or sentences. An email filter is a type of program that filters and separates emails into different folders based on specified criteria. For example, spam filters are an example. Semantic similarity analysis is a metric. Semantic similarity is a metric defined over a set of documents or terms where the idea of the distance between the items is based on the likeness of their meaning. Sentiment analysis is the process of detecting emotions in text. It's often used by business to detect sentiment in social data and understand customers. And knowledge extraction is the creation of knowledge from structured sources such as databases and XML. And unstructured sources such as text. On the right, you can see a search engine that understands the text given and then returns the code. Smart assistants. Smart assistants are devices loaded with software that you use to access information, perform tasks, or control other devices. Machine translation is automatically translating content from one language to another. Spell checking and typo correcting are done by comparing every word type with thousands of correctly spelled words and then using algorithms to determine the correct spelling. On the right, you can see the Siri interface, user interface. It's a smart assistant example. And on the bottom, you can see the Google's automatic translation. It's an example of machine translator. So common terms of NLP. Corpus. Well, you might know in machine learning, we need data. And here our data is text, which is called corpus. Corpus is a collection of text. There are some common corpuses, examples. Newshare collection has more than 500 million words. Brown corpus has 1 million words, and they are tagged and balanced. We will see what is tagged in a minute. And then Pen Tree Bank, 1 million words of parsed Wall Street Journal news text. And then I use in my Turkish projects WordShots 300,000 words Turkish corpora, and there's a link. On the right, you can see Rosetta Stone. It's used to understand hieroglyphs translation. And the thing is, on the top, on the middle, and on the bottom, the same thing is written, but on the top it's written with hieroglyphs. On the middle, it's written in Demotic, which is a more daily hieroglyph writing way, and on the bottom, it's written in Greek. Text normalization. Normalization is a process used to clean noise from unstructured text. Segmentation is the process of dividing written text into meaningful units, such as words, sentences, or topics. And tokenization is the process of tokenizing or splitting a string text into a list of tokens. Words are tokens in a sentence, and sentences are tokens in a graph. On the right, you can see tokenization of a sentence. The cat sat on the mat. The cat sat on the mat. And you can see punctuation is also divided as a token. And because of that, you generally delete punctuations before working on the text, but it also causes the meaning loss. Stemming is the process of reducing the words to their word stem or root form, hence aiding the preprocessing of text, words, and documents for text normalization. In computational linguistics, lemmatization is the algorithmic process of determining the lemma of a word based on its intended meaning. Part of speech, pause, a category of words that have similar grammatical properties, and pause tagging means process of marking up a word in a text as corresponding to a particular part of speech based on both its definition and its context. On the right, you can see the difference between stemming and lemmatization. Stemming just cuts the last part of words. On the other hand, lemmatization is a little more complex. It has a library of word lemmas, and by that it gets lemmas of these words, and it does a better job. And on the bottom, you can see part of speech tagging, their tags. For example, is that a word, is that a noun, etc., and other tagging as well. So, history of NLP. In the 1940s, after the World War II, people recognized the importance of translation and hoped to create a machine that could do this sort of translation automatically. However, the task was not easy as people first imagined. By 1958, some researchers were identifying significant issues in the development of NLP. One of them were Noam Chomsky, you can see on the right, found it is troubling that models of language recognize sentences that were nonsense but grammatically correct as equally irrelevant as sentences that were nonsense and not grammatically correct. Well, this sentence means models of language recognize sentences that were nonsense but grammatically correct. So, natural sentences, naturally occurring sentences, there are no formulas for them. You can't formalize them. For example, Yoda say, Yoda, you can call me, etc. And that's a kind of issue. And from 1958 to 1970, researchers split into two divisions concerning NLP, symbolic and stochastic. Symbolic or rule-based researchers focus on formal languages and generating syntax. The idea is to teach the machine how to understand languages in the same way as we humans have learned how to read and how to write. On the right top, you can see the symbolic rule-based understanding of the language. And stochastic researchers were more interested in statistical and probabilistic methods of NLP, working on problems of optical character recognition and pattern recognition between texts. And you can see the probabilistic way that it guesses, like if it's a noun, then for example it's a I, it's probably going to be am, etc. After 1970, researchers split even further. One new area was logic-based paradigms. Languages that focused on encoding rules and language and mathematical logic. This area of NLP research later contributed to the development of the programming language Prolog. Natural language understanding was another area of NLP that was particularly influenced by SHRDLU. This program placed a computer in a world of blocks. On the right you can see, enabling it to manipulate and answer questions about the blocks according to natural language instructions from the user. The computer is clearly able to resolve relationships between objects and understands certain ambiguities. On the right you can see SHRDLU, and it is in a block world and answers input text by the color, the shapes, and etc. By 1993, probabilistic and statistical methods of handling natural language processing were the most common types of models. Today, as the data production rate increases, ANNs start to work better. ANNs means artificial neural networks. And as the number of hidden layers of ANN increased along with the computational power, deep learning started to dominate this field. Deep learning is ANNs with more hidden layers. Let's say more than 5 hidden layers. But there is no such a thing as a count. The following algorithms are the latest leading algorithms in the NLP domain: RNN, repetitive neural networks, LSTM, long short-term memory, and attention-based algorithms. Well, RNN. Simple free-form neural network cannot completely understand the sequence of incoming data by reading a sentence and passing it on previously gathered information. To solve this problem, RNNs feed the hidden state value to itself to perform a loop, passing down much needed information. On the right, you can see there's input layer, output layer, and the hidden layer feeds itself, creates a loop. However, RNNs suffer from the problem of vanishing gradients, which hinders the learning of long data sequences. Gradients carry the information used in the RNN parameter update, and as the gradient gets smaller, the parameter updates become trivial, meaning no real learning is done. On the right bottom, you can see when it's at the it part, it really lost its what's meaning. You can see there's not much black color going on, and you can see you can imagine it like y equals to x multiplied by a multiplied by b multiplied by c multiplied by blah 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 blah. So one of them lost its meaning to so much that it's so close to zero, it lowers the output, and it is the brief example of vanishing gradients. So LSTM, long short-term memory helps for the long-term dependency requirement or solves short-term memory issue, as the default behavior is to remember long-term information. The primary component that makes LSTM is good is the presence of a cell state vector for each LSTM node, which is passed down every node in the chain. So there is a cell around every chain, and in that cell, it remembers better than RNN. But LSTM's disadvantages are it takes longer to train and use more memory and are easier to overfit. And to solve these problems, there's attention mechanisms. Neural networks in encoder-decoder structures need to be able to compress all the necessary information of a sentence into a fixed length vector. Therefore, the neural network cannot handle longer sentences than in the training corpus. Unlike a basic encoder-decoder, the attention mechanism helps to look at all hidden states from the encoder sequence for making predictions. Attention-based architecture attends every hidden state from each encoder node at all times, then makes predictions by using neural network to learn which encoder states will how much attend after deciding which one is more informative. The main disadvantage of the attention mechanism is that it adds more weight parameters to the model, which can increase the training time, especially if the input data for a model are long sequences. So it works by deciding which part joins more, which hidden state joins more, and there's another ANN that works for that goal. But the disadvantage is time really increases when the sentences length increase. The text corpus's length increase. So what are the common problems in NLP? Contextual words and phrases and homonyms, synonyms, irony and sarcasm, ambiguity, errors in text or speech, colloquialism and slang, domain-specific language, low-resource languages. On the right, you can see they are both a huge metal fan. So is it hard to make NLP projects? Well, you only need data that has natural language and a programming language environment to apply your algorithm. It is that easy to start doing natural language projects. Well, here are some of my project's outputs. On the right, you can see word sense disambiguation using the LASK algorithm. So there's a text, and some words are synonyms, and LASK algorithm decides which meaning belongs to the which word. And on the left, you can see frequently asked queries bot. It's COVID's data, and it uses BERT. On the right, you can see Turkish type of corrector. So I use 10,000 Turkish corpus, 10,000 synthesis Turkish corpus. So it finds the frequency of every single word and assumes that low frequency words are written wrong, and finds the similarity finds a similar word that to that word that frequency is higher and corrects it with it. And on the left, you can see language independent text summarizer. In this example, I summarized the first 10 lines of Hunger Games books, and it's summarized by 52%, but the disadvantage is its complexity was really high. So here are some latest NLPA projects. Here it's NVIDIA's a graphic card company's project from 2021, a paper, and it gets an input and then creates an image in real time at that moment. So the NLP part is not creating the image, but the understanding the input text. As you can see, it understands very good. And this is from OpenAI's GPT-3. OpenAI GPT gets an input text sentence and then creates a website, for example, like a Google, and then creates a LaTeX formula from your sentence, and also understands elementary level and university level questions and answers these questions. And this is also from OpenAI GPT-3. It explains assembly code in a plain English and then creates a Pong game or another game by just real-time text input. It's from 2021. Also, you can find these more about these projects in two minutes paper on YouTube. And this is from DeepMind 2022. So this AI solves programming problems, and it does a good job as well as an average human competitor. So it works like this. It gets pre-trained from GitHub, and then it's fine-tuned by problems and solutions. And afterwards, it has a wide variety of problems and their solutions in other languages, Python, C++, etc. And now filters these codes and creates its own solution, as you can see. Thank you for listening. And I would like to ask some questions. You can answer them in the comments. Which NLP application do you use in your daily life? Let me explain it. Let me answer it, sorry. For example, I use text-to-speech, speech-to-text on Google Translate, and also machine translation on Google Translate as well, for example. And other question is, which NLP application do you want to see in the future? Well, I am a big chatbot fan. I really want to see more human-like chatbots that pass the Turing tests. That's all my references. There are websites, books, and scientific papers. Thank you for listening.